Hey everyone, so today we have someone who spent their summer at Jane Street and they were first year, now they're only in their second year, but now they have interviews coming up at Bloomberg and Citadel. So we're just gonna quickly test his lead code skills. I'm gonna ask him a question. Let's see where he gets to in 20 minutes. All right. Okay, I'm gonna drop in the first question. It's been a while since we did one of these. I have videos where I was helping him when I was training him up for his interviews. I think he had one at Two Sigma, and I we went through three different sessions from simple BFS, DFS arrays all the way up to dynamic programming. But let's get into this first question. So I just posted in here. Go ahead and work through it.
Okay.
Or let me mention it at a high level. You're gonna be given a list of points in a XY, like a Cartesian plane. So a list of points xi and yi. We need to return the minimum area of a rectangle. We need to see what rectangle produces the minimum area given the points that I give you. Does that make sense?
Yeah.
So we need
So
to
it's
find
like,
4 points that make up the smallest rectangle area.
I see.
So I'll let you go ahead.
So, okay, so you
You
got
got 20
four.
minutes.
Okay. It's kind of hard to visualize because of like, well, it's like,
There's a
this,
drawing feature.
oh, there is, yeah. Okay, so let's say like my points are like, I'll just like make like a bunch of random points for oh shit, for visualization. Okay, so, and then I'm supposed to find 4 points. All right, that's not actually, no, the question doesn't even say that. The question says find the minimum area of,
The
that is made,
rectangle, yeah.
yeah, from 4 points.
Exactly.
So, let's see, one such thing could be. Well, I think okay, so I think a solution would be to uh, get every possible like set of parallel lines. So like it's not possible like just given 4 points, it's not possible to, like form a rectangle if they're just 4 points, right? Like it'll just be like a parallelogram or something. So I think the first step is like find every possible rectangle in the
Yeah.
brute force. So that would be something like well, the way I drew this is kind of weird. I think you'd
Like
have to like find every like given a line, given every possible line you can make from like one point to like the other,
mhm.
uh, see which other pair of point is like parallel to that. So like let's say this was one, then like a rectangle could be formed from this. It's probably like definitely like a better way to do it though, because like just finding every set of lines is like n squared. It's like every point like the other point. Um, and then finding like another parallel points is like another O of n squared. So I
Yeah.
think that's the approach. Let me see.
Wait, one part of the question is the points or the sides will be should be parallel to the x and y axes.
Uh,
So
the
we can't have a sideways
oh
rectangle like this.
oh wait, yeah, yeah. Oh, that's obvious. Yeah, yeah. Wait, no, it's not obvious. Oh, wait, yeah. I think that simplifies it a little bit. So oh wait, so the parallel lines are only allowed to be like flat. So this like that.
Essentially,
Like you're not. I see. You're not allowed to like have like diagonal lines. Okay,
you can't have a diagonal triangle.
not a triangle, but like this
Or
is what
sorry,
like a rectangle.
yeah, diagonal triangle. Or sorry, diagonal rectangle.
Yeah. Okay. Let me just make sure I'm reading the question carefully.
Yeah, go ahead, read it again.
Turn the minimum area of a rectangle formed from these points with sides parallel to x and y axes. There is not any such rectangle. Return 0. Okay, let me think about like why the output is 4 here. It's because uh 1 1 1 3 3 1 3 3. Yeah, so rectangle formed from 1, 1 to 1, 3. That is 3 long. Wait, 1, 1. Yeah, and 3, 1, 3. Okay, yeah, those are parallel lines. Okay. Um, so like, given a point here, in order to like find every possible rectangle, I want to see, like, in order to like form a rectangle, then with the constraints they give us, we need at least 2 points on the same x plane, and 2 points on the same y plane. So, and those same, let's see. Trying to think of a quick brute force, maybe. Um, maybe for each point. So like, let's say like for like 1, 1, for example. I'm just like make a new graph here. So they give us 1, 1, 1, 3, 3, 1, and 3, 3, and 2, 2, like somewhere in the middle here, which is irrelevant. Yeah. So let's like, we think like, so we'd go at to the point 1, 1, and then we think, okay, like what are the other points here that like form a parallel line? Those would be 3, 3. Like we looked for the rest of the array and we see like 3, 3. Not sorry, not 3, 3. 3, 1 gives us a parallel line, and 1, 3 gives us a parallel line. So, and then from that, can you say anything else about that? Actually, what if we went like x-axis by x-axis? It's like we look at x equals 1, or sorry, y equals 1. And then we see like, are there points here that like form a horizontal line? And like we go again for like x equals 2. Are there at least 2 points that form a horizontal line? And then keep going. But then like that's like terrible for efficiency because like you might like explore some x-axis that don't even like have points at your input, and also like the boundaries for it aren't well defined. Like for all we know, there could be like points in the negative right here.
Yep.
Okay, so like yeah, going through each x level probably, or sorry, y level probably wouldn't be a good solution. Let's see. I think the parallel part is interesting to me. Size axis does not intersect rectangle return 0. I think I'm getting a bit too overwhelmed with like the minimum area rectangle. Like, how would I find a rectangle? Like, given like much arbitrary points, how would I find the rectangles that exist on the plane?
Yep.
Let's see. So 1, 1, 1, 3, 3, 1, 3, 3, 2, 2. Has it been 20 minutes already?
No, you're still good. Been 9 minutes.
Oh.
What are you thinking? So I think that's a good insight. You
I
said
think
how do I even find out if something if a rectangle is in there, or
I
how do I
think
even
before,
find? Go ahead.
yeah, I think before when I said something like when they give us like 1, 1, 1, 3, right? I said like if we have like this, if we know like we have like a parallel point here and like a parallel point here, it's like the thing I was stuck on is like how do we like get the relationship for like this point here? Because this is not on the same plane. There's like I don't know what you call it, like not perpendicular. That's like the wrong word. Like maybe like part of the problem could also be like finding like triangles instead of like the full rectangle. So like finding a set of 3 points and then see if like this fourth point over here exists. Like find the triangles.
Here,
So it's like given 3 points, then like the next step is like does a fourth, because like if we have like this set of points right here, then like we know to like we know the coordinate of this point over here. Like we know the coordinates checked for it in the array. It's like if that point exists, and this is a triangle, this is a rectangle. Does that make sense?
yeah.
So
So you're trying to calculate. You want to be able to calculate the fourth point once you figure out 3 points.
yeah, like given 3 points, let me see if the fourth point exists in the array.
And then what happens if it does?
If it does, that's like one such triangle. That's like one such rectangle that we can like consider. And then we like compute the array of that, or sorry, compute the area of that. And then I'm thinking we could do like not two passes of the array, but like two like conceptual passes of the problem. So like one step would be form every rectangle. So a really naive thing to do. I think I sort of have like a before solution. So like given our points array, right? We sort of find every combination of 3. So like we take like 1, 1, 1, 3, 3, 1, and then here like we calculate like, what's the logical fourth point? It's 3, 3. So we like look in the array and we'd see 3, 3. And then if it exists, then we add it to like another rectangles array or something. And we like add the area of that rectangle to like the rectangles array. Or not even actually, we just have like a running maximum or something. And then like we'd move on with like another rectangle. So I think one other rectangle here was like let me see, like 1, 1, 1, 3, 3, 1, 3, 3, and 2, 2.
Yeah.
Oh, so I guess one triangle that we could form was like this is like one such triangle, right? And then we look, or this is not, no, actually, I want to like clarify my definition. I only want right triangles because there's the only ones
Right
like making right.
triangle. Okay.
Yeah. So like we'd expect like a point to be here. And so we like calculate that position, but then we wouldn't find it within the points array. So that's like not a rectangle. And so like so on and like we try every combination of 3 points within this points array. And if we find like a valid rectangle by forming a triangle, then we calculate the area and then keep track of the maximum. Does that make sense?
Okay, so like a triple for loop type thing, like these 3 points, check if the fourth point exists.
Yeah.
Yeah, I mean, it sounds like it would work.
Yeah, but I think the heavy lifting there is like finding every pair of 3 points. I think that's like a lot of work to do.
Is
Um,
there is there a way to calculate the points with less than knowing less than 3?
I mean, I guess if you have like 2 points, like two opposite like vertices, it's like top left or like bottom right, like bottom left or like top right, then you know. Oh yeah, I guess like you've like constrained the problem. Then like then you know like the position of the other 2 points. But like that still narrows it down from like 3 points in your rate to like 2 points. It's like what can we do with that information? Then so like within the points array, like for every point, you would within the points array, you go to the rest of the array, and like for every point, you would compute the two remaining points. So like if you get like the bottom left and the top right, then we look at top left and bottom right. Like we compute those and we see if those two exist in the array, points array, and then if they do, like we compute the area and then we add it, like we keep track of like a maximum. I think that solution probably works. I think the complexity of that would be, it's like first you like for every point, you go through every other point, and then find two pairs, and then you also like look through the array again to see if those remaining 2 points exist. I think that would be like O(n) squared. Wait, so it'd be like an outer loop, and then within the inner loop, you're doing like n work within the inner loop to search for the remaining two vertices, which I think would be like n cubed work.
Is there a
So I'm
faster
not
way to find the other point if the other points exist?
sorry.
Is there a faster way to find how if the other points exist?
Um, given the array as it is, I don't think so. Probably like something we can do with
So
the
you're
input
saying
though.
once we find 2 points, we're gonna search for point three and point four, but the way we're gonna search for point three and point four is by looping through the array looking for those points.
Yeah, that's like the most naive thing I think I can think of right now.
Like, what's the fastest way to look things up? That's
Yeah,
faster than Oven.
I mean the fastest way to like looking this up is with the hash table, but I'm not sure what the. Oh wait, no, we don't need. Yeah, we just care if it's like there, like a lookup check. I think a hash set would probably like be fine then. Like we
Mm.
just want to check if like the point exists, and not necessarily like want to like modify like access anything with it. So I think wait, yeah, I think you just like have to like convert the points to a set, um, and then for every point, it's like for every given point within our set, we loop through the rest of the points set, um, and then compute the remaining 2 points, see if they're in the set, and if they are, compute the area of the rectangle formed by those 4 points altogether, and I keep track of like a running maximum. Does that make sense?
Yeah, go ahead and implement because we're already at 17 minutes.
Oh shit.
Go quick, go
Oops.
quick.
So we have our points. So I think Python tests are iterable, so this should probably work. So for point and points, so for and now you want to compute running points. So you have like top left, bottom right. Um, definitely is like a clever formula for this with like min and max. It's like you don't really care if it's like bottom right, like top right. Um, it's like before it's like if.
What if it's not less than?
Then it wouldn't be top left.
What do we
There's
want to
definitely
do?
there's definitely like a clever formula for this. But are we given tuples or are we given arrays?
This is the input we're given.
So it's arrays, right?
Yeah.
like not tuples.
Mm.
Uh, oh wait, I don't think this first step would even work then, because like only tuples are hashable, because like lists are immutable. Like assuming that works though, then oh no, I think you could do something like set.
Yo, congrats on your Roblox interviews. Do you have any advice for Roblox? I don't know. I've never done one before, but congrats because I know they
That would
asked you like the hardest questions in the OA. So just
for
passing is
point
wild.
endpoints,
Just do tagged
tag
questions.
point endpoints. But I sort of know what I have to do, but it's just like a lot of. There definitely is a clever way to do it. The way I'm thinking right now is like I just like check if, oh, if this point's x coordinate is less than that one, then it's like the top left, and I want to find the bottom left point, and I want to find the top right point. Like I'm basically like going through like each possible case where, okay, do we have top left, bottom right? Do we have bottom left, top right? Do we have? Oh wait, are those the only two ones? Oh, and like vice versa, because one could be less than the other. Actually, I think we could. I'll make sure like uh the first point is the one that comes before. Okay, now I've like sort of normalized it. Okay, so now is it top left, bottom right, or bottom left, top right? So like this one. And I want to compute bottom left is equal to the left 0 with the right y.
So what are these different cases?
So so before this, like we've normalized it to where this left point is always gonna like appear to like the left of the right point. And so once we're sure of that, then I have like two cases. One is our 2 points are such that like the left one is on the top left and the right one is on the bottom right. And the other one is going to be like if left one or like just like else pretty much, then it's going to be bottom left, top right, because that like affects how we compute the other vertices.
Yeah.
Does that make sense? Yeah. Top right, bottom left, top right. Top right, right. Yeah, right's x-axis, and then
Okay. Let's say in your for loop, it says for left in points, for right in points.
Yeah.
Could we just skip if left, or should like we only execute the code if we actually have the top left and the bottom right?
I guess yeah. If like yeah if yeah because it's like n squared. Yeah, you're right. So we would like that. That'll work too. And then if left 0, if left is +1. So once we have that, we just check if bottom left and no wait, that's not how that works. If bottom left in points and top right in points, then add a result here. Area is equal to max the current area.
We're trying to minimize the array.
Sorry?
We want to return the minimum area.
Oh yeah. Min area and area formula is just top right 0 length times width is like
Okay, I think I have another person coming up, so this is a good stopping point. How do you think you did? How was that?
thought it was pretty terrible. I mean I think I was a bit stuck. I think I was like complicating a lot at the start. Like I was like thinking there was like a very math heavy way of doing it. There was like something that I wasn't looking at. And so I was like focusing on like some property of the problem that I could like exploit. Like have you ever seen like those weird like math LeetCode problems?
Mm-hmm.
Um I think this one ended up being like a lot simpler than I thought. And like the solution was like really right in front of me the whole time. Um
Yeah.
yeah, this was like a lot. This is like a pretty easy problem, I can't lie. I just like kind of fumbled it.
Yeah. I think the main thing is you're just working through this massive example. Like if you look in the drawing, you just have all these different points and you're trying to figure out the triangle or squares in there or rectangles in there, then you're working with triangles. I think just work through a very small example at first. Instead of going through a large example with no clear answer, work through the small example that I gave you that has a clear answer. And then I think you would have got to the brute force a lot faster, which was just figure out all the rectangles and
Yeah,
then
makes sense.
calculate the area of those rectangles and just take the minimum of those. And then it would just break it down further. Oh, what's the fastest way to find all the triangle or find all the rectangles? And I think you were getting there, but it's just with that big example, it was hard and you were just spinning your wheels a bit for a while on
Yeah.
that. But yeah, and then just practice on simplifying your code. So is there ways that you can reduce all of the cases? So you're originally going to be having a ton of cases there and your for loop would have got complicated if you had any bugs in it. You would have not been able to debug it in time. So that's why I
Yeah.
gave the small hint of like if it's only look for the top left and the bottom right, and if the 2 points that you have isn't the top left and the bottom right, just skip over it.
Wait, could you repeat that? Like, what was the problem with it before? Like, I get like they're both the same. I think the way that you have it, the way that you search is like a lot more cleaner.
Yeah,
But like,
because you just have
yeah,
to capture because essentially your algorithm would find the find 2 points and then you'd have to handle all the different cases. It actually might be the top light. You might have like your first for loop might actually be the top left and the bottom right, or it could be the bottom right and the top left reverse, or it could be the bottom left and the top right. Like you know what I mean? But all you really care about is the top left and the bottom right,
Yeah, yeah,
because uh because then you'll only check it once. Like you won't really
yeah.
save on
I
runtime
get what
with
you mean.
all. Yeah, yeah. I don't know
Like
if
if
that
like a
goes clear.
bottom left and if like a top right and a bottom left exist, then like the reverse is also true. Like
Yeah, exactly. So just wait until you
yeah, yeah,
see until you
wait,
have
yeah,
like the right points there. So for
yeah,
example, a bottom left and a top right. I don't care about those points because I'll eventually check it once I get the top left and the bottom right
yeah,
through the loop. And then I'll just check it, and that saves me a lot of cases. So just simple things like that, I think in a lot of questions, you can find ways to reduce all the boundary cases or reduce all the cases. For example, when working with linked lists, you could like add in those sentinel nodes, and that reduces the boundary cases a lot.
yeah,
And like with two pointer solutions, there's always neat tricks to reduce the boundary cases, and that was just a small one. I'm sure you would have got to it in time. I think for this one it was just working with a small example and figuring out how to solve it on a small example and then working your way up from there instead of starting with a massive example and then getting to the solution slower.
yeah. Makes sense.
Yeah. Cool. All
That's
right. Thanks for coming out.
yeah.
Appreciate you, man. Good luck on all
Thank
your interviews. You got this.
yeah. Thank you.
Yeah.